If you haven't seen the chain rule before, the simple version is that if you have a function that could be composed of another function, then the derivative is found by evaluating the derivative of the outermost function, it's h prime, with the innermost function kept the same inside of it. But then you chain on the derivative of the innermost function. So there, that's the chain rule. So in this problem, the outermost function would be just a square root function, and the innermost function would be 1 minus 3x squared. That way, because if you compose h of g of x, it would turn back into this function. So all we need to do to evaluate the derivative of y with respect to x is evaluate the derivative of the outermost function, so h prime. And remember, that's 1/2, or you could say square root of x in the denominator. Because remember, a square root is a 1/2 power. So the 1/2 comes down, multiplies, and then it gets reduced by 1. So that becomes negative 1/2. So instead of having x to the negative 1/2, you could, maybe jumping over too many, you could have, yeah, let me just not jump over steps here. H of x, another way of writing it is x to the 1/2 power. So if I want h prime, I'll have to do it over here. Using the power rule, the 1/2 comes down and multiplies, then the power gets reduced by 1. So another way of writing that, instead of having negative exponents, is you could put the x in the denominator. So that's 1 over 2 square roots of x, if you like. Okay, so basically with this problem, the derivative of y, using the power rule, the 1/2 comes down on that square root. The innermost function is kept the same in the chain rule, on the first step at least. Now it's to the negative 1/2 power, and then we multiply it by the derivative of the innermost function next, g prime in the example I had over there. So the derivative of the inside, using the power rule, the 2 comes down, multiplies, makes negative 6x. So another way of writing this, you could put the square root in the denominator. This is negative 6x over 2 square roots of 1 minus 3x squared, or you could simplify the coefficients. Negative 6 divided by 2, and it makes negative 3. So that's an answer format that Newton should like. So this one just asks you to use a formula for the chain rule. If you want to find dy dx, then find dy of some other variable u multiplied by du dx. And so they've defined a y and a u for us. They've it's like unraveling the function we just looked at in the last problem and making it and turning it into those two functions that are composites of one another. Because like the original function that they might be looking at might be this. Not might be, it is this. Yeah. So, I mean, if you looked at it like this, you could simplify using the exponent properties and evaluating the derivatives just using the power rule. But let's do the way they want us to do it. Let's find dy with respect to u. So derivative of y with respect to u is 20u to the third. And the derivative of 2 is just nothing. And the derivative of u with respect to x, 3 comes down and multiplies, it makes 9x squared. So dy dx equals all this stuff. We can just plug it in now. We know what dy du is. It's 20 u to the third. And we know what du dx is. That's 9x squared. And then we know what u is in terms of x. It's 3 times x to the third. Then we can simplify 3 times x to the third. Oh, oops, the third should be on the outside there. Oh no, we need an extra third. Oh no, it's not that it should be on the outside. We need an extra. U is being raised to the third power according to our derivative. And u is also equal to 3x to the third, so I dropped a third there on accident. So this is 20 times 3 to the third x to the ninth, because the powers on top and powers multiply. And then, so that's 20 times 27 is 540. And then times this other 9 while we're at it. 4,860. That's x to the ninth times x to the second. That makes x to the 11th. And I think we're done now. 20 times 27 times 9. Yeah, okay, so that's our derivative after we simplify. So they want us to evaluate the derivative at -1. So we need to know the derivative of h of x. So there's an outermost function here. 3 comes down. Innermost function stays the same. We're just using the power rule in the outermost function. And now we multiply by the derivative of the innermost function. So this derivative isn't too bad because they're separated. They're different terms, so we don't have to use the product rule. The derivative of x to the fourth is 4x to the third. And then the derivative of p of x is p prime of x. And so they want us to evaluate it when x equals -1. So we're going to put a -1 in for x. And so -1 to the fourth power is just 1. P of -1, that's p and not p prime. So p of x when x equals -1 is -2 according to this table. And then -1 to the third power is -1. -1 times 4 is -4. And then p prime of -1. So this is the derivative of p. This is -1. That matches up to be a value of 3 according to the table. Okay, so some quick math here. 1 plus -2 makes -1. 3 times -1 makes -3. So we got -3 on the left side. -4 plus 3 is -1. -3 times -1 makes +3. Oops, so I found a mistake. When I copied down, I forgot the square here. And so 1 plus -2 does make -1, but that's supposed to be squared. So 3 times +1 times -1 should make -3, not +3.